All right, now I'm looking for points of inflection for this quintic. So first derivative is going to be 5x to the fourth minus 15x squared. Second derivative is going to be 20x cubed minus 30x. So setting the second derivative equal to 0, because that's where my points of inflection will be, I will factor out 10x, 2x squared minus 3. So x is equal to 0, or x is plus or minus root 3 halves. So all of these are where the second derivative is equal to 0. I have not been asked for any points of inflection, so I don't know whether these are stationary or not. However, just by looking at this, I see that this is going to factor out as 5x squared, x squared minus 3. So if I set my first derivative equal to 0, I see 0, 0 is a stationary point of inflection. For these x values, I'm going to have non-stationary points of inflection because I know that these are not solutions to the first derivative being equal to 0. So I'll have a stationary point of inflection, and these are non-stationary. And then to find my y values, of course, I'm going to plug in the x's. So I've got 0, 0 as my stationary point of inflection. I will have root 3 over 2, and then that's going to be 3 halves times 3 halves would be x to the fourth. So that's going to be 9 over 4 root 3 over root 2, and then the, that's going to be negative, and then plugging in my negative, I would, oh, goodness gracious. That will be negative, sorry. This one will be positive, and then I'll subtract. 5 times 3 is going to be 15 over 2, root 3, root 2. That's my first non-stationary point of inflection. The second is plugging in negative root 3 over 2, which will give me negative 9 root 3 for root 2 plus 15 root 3 over 2 root 2. So there's our points of inflection.